prompt your responsibility. Okay. Okay, this is the actual logic that happens inside. When you give a word, and I'm not sure if you are attentive to this kind of first word I told you something called M. This is some number weightage given to the word. After that, you have three values that is associated with each word. One is the key, another is a value, and another is queries. Okay. So queries will tell you like the context. You give multiple queries, you will know the context of that word. Key is exactly the positioning. Value is the exact value of it. Okay. So you have three aspects to each of these. I'm not sure, is it visible? Okay. So based on that, you come up with something called soft max. So I have a sentence that was fun. Okay. So now we are given the soft max of 0.93, was 0.01, fun 0.06. Deciding which and giving more probability to that word, and then lessening the probability of the other words according to the context and the importance of that word in the sentence. So that is the way you are giving something called soft max. Then what happens is each word is weighed in relation to the other word. So there's a matrix that is formed when each word will be compared with the other words, and there is a weightage given to the word. So that is the way the internal computation happens. Maybe if you just look at this is what happens. You embed it with a time. See, this is a word. So G student is a I am a student. So now the first each word enters in, and what happens? There's the embedding that happens here. There's an encoding that happens after that, and then each word the key value queries is fetched, and then it comes with a weightage. And in the database for G, what is the translation is fetched. So you have the correlation between French and English. So it comes out with I. I am a student. So that is the way this moves through the encoder, then it moves through the series of decoder, and then it comes to the linear and softmax classification, and finally you get the outcome. So maybe if you go in much deeper, you will learn about the mathematical algorithms used in the encoder and decoder. That will make you understand more in depth how the text classification happens. So I don't know if you take that yet. Okay. So we are more or less done with transformer. So you have some basic understanding of transformer. We'll move to GANs. Okay, what is GANs? What is GANs? Generative adversarial network. Okay. So now GANs is primarily this the previous model transformer is primarily used for sequential translations. Okay, text. GANs is used for it is used for unlabeled image processing. It's a more advanced form. So you have there are various algorithms that comes in. So you just I'll give you a basic thing like encoding and decoding. For GANs, you have something called generator and discriminator. What is it called? Generator and discriminator. So you see here, this is a generator. So in this generator, you are going to just feed some noise. So noise is what? Nothing. Okay. So it's some dumb image, some scribbled image. Okay, just giving it. Now what this happens is from the discriminator you get some output that goes back into the generator. Okay, and this generator will generate some fake image. So there are multi-processed neural networks that is used inside the generator. With that, there is a probability calculation that it does, and it generates a fake image. And this discriminator's job is to tell the input that is given to it is fake or real. So here is a training set that has real data. I feed 100 faces through this training set. And the training set goes into the discriminator. I am trying to fool the discriminator by sending fake image here. And discriminator has to tell me this is a real image or a fake. Now what happens if there is a wrong prediction here? So that goes back here as input to the generator. So you keep training data, keep this process keeps following, keep sending data, keep training, keep training. At some point, what will happen? The outcome of the generator will start matching the real image you're going to send in. That is how going to make your generative AI intelligent to generate faces, to generate facts. We have generative AI machines or programs that are automatically generating cats, dogs, even movies. So how is that? The first thing is you are unintentionally or intentionally are feeding intelligence into the generator. How are you doing it? You are just giving a discriminator to make the generator intelligent by just finding whether it is the outcome is real or fake. So the mathematical calculation, I'm not sure if you are familiar with this binary entropy. So this is a mathematical calculation that goes behind. Okay. So at most the problem is later on generative AI, the solution they came up with the probability theorem. We have in mathematics introduced probability. Why do they introduce probability? To reduce the data content. So if you don't have probability, you need lot of data. When you have probability, you can say probably this can be a cat. Probably you give the probability percentage. So based on probability, you're reducing the data weightage, and so that way you're trying to come up with an outcome. Okay? So this is the actual probability theorem that is used here. I don't want you to overload you with this. You can have to understand this. So this is y log n. So 1 minus y log n. So this is actually what you call d here is the discriminator. Okay. And this is a generator. So generator is here. So you're feeding noise into the generator. Generator is generating some image, okay? Say something like this called the theta of G. And then what happens to that noise? That gets reconstructed here, and then you have the real data, original data coming in here. Now this D is job to tell that this is correct or this is correct. So then you have certain amount of point visualization incorrect thing that goes again as input to G. Okay. So maybe this will clearly show you, maybe some understanding you will get on this. You see this noise, it is just some nonsense here. Okay. And now this is the real data that is being fed here. And this is the generated data. So after it goes to the generator, this noise is trying to shape up and understand what the real data looks like. See the format it's trying to make itself bend to this format. And slowly what happens is this generated data starts following the footsteps of the real data. At some point, what happens? The discriminated probability is 1 by 2. Probability is 1 by 2 means what? It categorizes fake data as 0, real data as 1. So at some point of time, your noise what you're going to generate, it is going to match with your real data, and your generator is very intelligent. It's going to generate exact images similar to what you have trained it. Okay? So now you say to tell to the generator at this point, please generate a cat for me. So if it's already trained with a cat, it will generate for you a cat image and show it. How does it generate? Because it already is trained with how a cat looks like. So that is the so this is the steps that is followed here. First is done on real image. Then the discriminator there is a loss. See how much close and real image. That loss percentage or the dot value is calculated, and then it generates fake images from the noise. After that, there is a thing to turn on the fake images. Then you propagate the discriminator loss, propagate the generator loss. So both these go again. Cycles. So keep training data, this goes in cycle, and somehow over time, very can you say that the generator is perfect, it can behave like a generative AI to take any data or output any data for you. Then the discriminator value comes to 1 by 2 and is exactly able to distinguish between the real and the fake, and this starts generating real data. So that's the amount of training you're going to give to the generator. Okay. See this is the natural flow. So you have the discriminator here, right? And your what? Real images. So now what happens? The discriminator is going to find out the loss. Okay? How much close I am with the real image or not. At some point of time, see, now finally, at some point of time, you start getting some figure like a cat. Who is generating that? Generator. How is it generating? Because it has been trained with data and has got the intelligence of how a cat should look like. Okay, that is the way, based on the probability theorem, it is calculated. Okay, I have a small video, just a 3 minutes video. Maybe just listen to it. It will give you a clear picture of the internal algorithm on how a dance looks like. Because this is going to be the Audio is not playing. Okay, I'm not sure why audio is not playing. That's okay. Put in full screen. It's not playing. Just trying to understand this. So, see here. See here. This is a generator. Okay. I'm feeding noise. One side I'm feeding real samples into the discriminator. From the other side I'm feeding the fake samples. Discriminator is trying to understand who is real and who is fake. See how it is changing the probabilities of the fake and trying to make it real. This is a distribution. Is trying to match the real. So at some point, gets to understand what is the real image or how the real image is. See how it is positioning itself. It's understanding the distribution. Any of you working on these training models? Trying to know. You can go to Collab Research. If you don't have a Python environment, go to Collab Research. It's some small Python program. Try to write a generator and a discriminator. Okay. So I think lot of code is available for generator and discriminator. You try uh, giving different photos of your faces and try to see if the generator is going to generate your face. I'll give it as an exercise to all of you. Okay? If you go to Collab and try, so the generator is intended to generate face. It knows if you say this, it will generate it. How does it generate? It already has been trained with the different facial expressions of the same person. Okay, try it out. I don't know if it's visible or not. For me, at least it's not visible. The text is not visible, right? Okay, this was I just wanted to show this because it will actually help you get a clear picture of what I explained so far. And coming to the practice session, I don't want you to bore you with the Python details. Okay. So this is what I've explained. So there are certain cases, okay, different expression of. I've picked maybe around 1,563 different images. Okay. And there's something called epoch. Epoch is training the model with the same data multiple times, so it perceives things differently. So I have 10 epoch training with 1,563 data sets. So this is a Python code. So you can get a lot of Python code if you go onto the internet and search. So this does nothing but I just import the package I need in the first part. Can't see it. Okay, and then I write a class for generator. Write a class for discriminator. So two items we need is generator and discriminator. And then I do the algorithm. So it's a tedious process where you have to train forward and backward. At some point, I have to. This is the steps where when if you run this, it takes time for training. So this has run it and it has given a lot of training. See, 2 epochs, 3 epochs, 10 times it has trained with the data. And finally, when I run it and make the generator run the data, see I've got it. So 1500, this is the clarity I get. Okay. You give a lot of data, you start getting this picture more clear. So you can with this, you can only guess that is a car. This is a very difficult to guess. Okay. So this is the way the picture gets generated based on the amount of data you are giving to train the model. Okay. So I think that's all I have. And do you have any questions or free to take it? Did you understand the basics of generative AI and so GANs and transformer? So these both, I think tomorrow people may come up with new models. You people also can research and come up with new models. It is your choice.